was yesterday, if you could, that'd be great. Remind me what the book page was. So, hang on one second. The page, I think it was 292, wasn't it?
Yeah, 2 through 10, number 13, 15, and
2 through 10, 13, 16, and 18. Okay, I want to make a short change to it right here. I know I said done by Friday, right?
Yeah.
Okay, I want to move this to Monday for you, all right? So we're going to say due Monday.
We don't have school on Monday.
Okay, then. How about we make it due Tuesday? You guys know why you don't have school on Monday? Because
today?
really? I thought I was going to give you the day off. But you don't want to give me the credit for it? It's no fair. I have to be here all day, but you don't.
Really? You have to be here?
All day.
That's
I don't know what we're meeting about yet. Okay, so double check, make sure you got that down. Savannah, let me know when you got it, kiddo. Everybody else have that down? Everybody else have it? Okay, gang, here's what I'd kind of like to do right here. I'd kind of like to just maybe revisit one of the problems that we did yesterday. And I think I'll pick this first one right here and see what it is that we recall from yesterday. And kind of want to finish up the notes and give you some time. Guys, yesterday we said we were solving systems of equations by substituting. All right? And we said when you start this, when you're solving for two unknowns and two equations, you always want to go through and find what it is that's all by itself. Now, in that first problem up there from yesterday that we've already got written down, hopefully, which variable is all alone? Which variable is all alone is number one? N was. And I said, I think that maybe I should suggest circling N. And what do we say N was equivalent to? Like the $10 bill yesterday was equivalent to, what did you give me yesterday, Brianna? 5 and 5 ones? And we said, you know what? If we made that trade, we'd each have the same amount of money, right? Just in a different form. It's kind of like saying if I trade N for something, what can I trade N for? Well, I can trade it for 5M. Okay? Now you guys remind me, but did we get all the way through these three problems? Where are we at? Just so you guys remind me. So we're at the application. So we did get all three of those done yesterday, right? Yeah. Okay, so just real quickly remind me what I would say then. If N is equivalent to 5M, meaning anywhere where I have an N, we're going to take what's up top and apply it to the bottom. So if I circled N up top, what should I circle down below? N. And what are you going to replace that second N with? 5M. So what I'm going to do is rewrite this second equation as 2M plus 3, and the idea was that if you ever substitute something, you must always parentheses around the equivalency. So we're going to replace this N right here with what?
5M.
And that was equal to 51, right? Okay, well this became 2M. How about the product of 3 and 5M? 15M. And this was still equal to 51. By like terms now, what do you have on the left? 17M. And this is 51. And when we divided, I think we got M was 3, right? Right? So we were pretty good on this yesterday. Okay, once I found M equal to 3, we came up and chose one of the equations. And I chose the shorter of the two. All right, so we know the M value. Once I know what M is, we've got to find your N value. I said rewrite one of these equations. Doesn't matter. I always pick the one that looks the shortest or easiest to work with. So I'm going to write down that 5M is equal to N, knowing that M was what value from down here? 3. So in for M, what can you substitute in right there?
3.
So you've got 5 times 3 equal to N. Well, that's pretty simple. What is the product there? 15. And we showed how yesterday that when I plugged 15 in for N and 3 into M for both of these, that both equations would be true at the same time. That's what it means to have a solution for a system of equations. Those two answers will make both equations true at the same time. Okay? All right, so I'm going to say, yeah, I think I got that yesterday. I think you guys did a really good job with it yesterday. Feel pretty good about it? Okay? All right. Sorry. All right, kids. on down to the application part and see if we can't figure out what the heck is going on here. Now guys, again, when you start talking systems of equations and start talking how do they relate to applications, I just want to throw this out at you. Is it easier to solve problems with few variables in it or with a ton of variables in it? Just a few, right? Okay. So the fewer variables I can write equations with, the better off we're going to be, right? Anytime you have an application, it might be your benefit to draw a picture. Two angles are supplementary. The measure of one angle is 20 less than the other angle. What's the measure of each angle? Ooh boy, how many angles are we talking about? What's it say again? Two angles right here, right? Two angles are supplementary. Hey, remind me again what supplementary means. What does that add up to? 180. So is 180 like a right angle or is it a straight angle? A straight angle. So I'm going to draw a straight angle here. You'll want to draw this picture as well. Okay, here's my straight angle right here. Okay? But it says that two angles make that straight angle up, right? So thoughts on what that might look like? There's just going to be some kind of a ray running out here. How many angles are formed here? There's two of them, right? And these two angles put together form this straight angle at the bottom, right? So if I called this angle 1 up here and this angle 2, which I'll just kind of set off to the side, I would say angle 1 and angle 2, those two angles have to add up to how many degrees, kiddos? 180. That's what supplementary means. So you might want to make a note right here. Supplementary means adds up to how much?
180.
Adds up to 180 degrees. Very good. Okay, what does it say about one of the angles? Second sentence. It says the measure of one angle is 20 less than the other angle. Okay? That makes sense to you? One angle is 20 less than the other angle. Well, do we even know what the angles are to begin with?
No.
Okay? Which angle looks like the smaller one? The one on the left or the one on the right? Okay, so the one on the right, I'm going to go ahead and call this x degrees. Is that fair, kids? Is it okay if I call that x degrees? All right. Well, if the first angle is x degrees, it says the other angle is what again? 20 less than that, right? Got a question? This angle's 20 less than this one, so what would an expression look like for the angle on the left? What would 20 less than x look like? Say it again, Peyton. Very good. Is this angle 20 less than this one right here? Is this angle on the left 20 less than the one on the right?
Yeah.
It is. Okay. So now we've got an expression written for the two angles that we're trying to solve for. Here we go. Here we go. I'm going to take these two angles and, what's the word? Add them up and set it equal to. Okay, so what's the equation going to look like to start this, kiddos? X minus what? That's the first angle, plus the other angle. And those have to add up to how much? Very nice, right? Help me simplify the left side before we move any further. 2x minus 20 is, all right, carry on, I'm done talking. Anybody? Add 20. Good, good. All right. All right, how about the right side, Izzy? 200. Okay, so what's 200 divided by 2, kiddos? So my x value is 100. I'm done, right? What do I have to do? Yep, I got to come back in and substitute in, because really, what are we trying to find? Well, it says what is the measure of each angle, right? How many angles are we trying to find here? Two of them, right? would you have for the angle on the right if it's just x degrees? 100 degrees, right? That's what x is. What are you going to have over here on the left? Why 80? Subtract the 20. That's what it says. Take the 100 minus 20. Got 80 degrees. I'll be a tickle monster in a little kid's store. Holy cow. Tickle monster in a little kid's store. What does 180 add up to? Well, oh my tickle. That's good, isn't it? Because what do we want those two angles to add up to? 180. Hey, is 80, 20 less than 100? I'd say we're probably right. You know what I love about this stuff? Once you get an answer, can't you go back and ask yourself, does this even make sense? Yeah. Does it work in the original part? If you put something down as an answer and just move on without checking to say, hey, does this make sense? Or can I substitute stuff back in to validate what I've done? Kind of hurting yourself, right? Because what we're finding out about all of these is I can always go back in and check to see if what we're doing is correct, right? And if what you're doing is incorrect, you might want to go back and fix some mistakes, okay? All right, questions on that page at all? You guys are doing a great job. All right, I want to touch on one more thing here today, and then I'm going to get you going on some stuff, so we're just about done here. Why don't you guys flip over to page 3 for me real quickly. Not going to worry about this today. So just put a big X right here. This is not going to be anything we're going to worry about today. What I do want to talk about, though, is this idea of rewriting systems of equations right here. All right, so I'm going to split this up. You're going to want to make sure you pay good attention here. Let's see. You might want to make something up like I've made right there, okay? Might want to make something up like I've made right there. The word I'm going to highlight right here is examples of having to do what? Rewrite systems of equations, okay? We're going to have to change a few things around. Now here's the situation. When I say rewriting stuff, I'm simply saying this. We need to change one equation. All right. If I go back to that second page right there where we were solving those systems of equations and the 3 problems from yesterday, I always circled a letter that was all alone, right? First, I circled a letter that was all alone on one side of the equal sign. Got a question for you. Is negative 3x all alone? No. Is y all alone? Well, kind of, but it's got, is it all by itself just on the left side of the equal sign here? It isn't, is it? There's more stuff on the left side with y, isn't there? Okay. If I look at this right here, I've got a 3x, a y, a 2x, and another 3y right here. Of those 4 that I just pointed at, which one looks like it could be alone easiest? The 1y, right? Okay, you want to find the one that's like a 1y to be alone. Okay, so here's what we're going to do. I'm going to circle this right here and say, you know what, that's the one that would probably be easiest to get alone, right there. So right here, kiddos, if I wanted this positive y to be alone, right here, what do I have to get rid of that's on the same side as that? The negative 3x. We would really like to take this negative 3x and move it to the opposite side, wouldn't we? Well, how would I get rid of a negative 3x on the left? Add a 3x. So if I add 3x right here, doesn't that cancel it? And if I added 3x to the left side, you would also have to add 3x to the right. Okay, so from this right here, by doing that, would you buy that, you know what, by adding 3x, what's all over here now by itself? The y is. So you've got y equal to what? Well, negative 7 plus 3x. You guys okay with that? All right, so how does that help us? Well, by rewriting that first equation, do you now have a variable all by itself right here? I do. Y is all by itself on one side of the equal sign. Y is all alone right here on the left side. And what's that equivalency, or what would you substitute in for Y? -7 plus 3x. Okay, so right here, in this set, it says, you know what, we're going to do examples of rewriting systems of equations, and we said we have to do what? Change one equation. So what I want you to do in this second box right down here that I have is this. This is the part where I want you to rewrite the system and then start working with it. So here's what we're going to call this. We're going to call this first equation that I changed, not what it was originally. The one you changed up here is going to get rewritten. So what are we going to write it as?
Y equals -7 plus 3x.
Okay, that's the one that got rewritten. And it said to change how many equations? One of them, right? Change just one of them. So how about your second one? Are we changing that one if I've already changed the first one? No, so just rewrite the second one. Here we go. The second equation is now 2x minus 3y equals 7. So let's move on this and see what we come up with. Here, we had to get a variable all alone because it wasn't given to us all alone in the beginning, right? Okay. Well, which variable is all alone now? In these two equations, which variable is all alone? Y is alone. Okay? That's like the $10 bill. We're going to replace the $10 bill in the second equation with what? So we're going to come down here and say, okay, this is the one we're going to change down below. So right here, we're going to change that y value to what I've underlined. All right? So we're going to the equation where a variable isn't alone. So let's rewrite this second equation in terms of x this time. So we're going to have 2x minus the 3. What's going in for this y that I have circled now? -7 plus 3x. You bet y is that mess right there. So we'll replace the y with that mess. And what's this still equal to, kiddos? Okay, all I've done is substitute y's equivalency in there. All right. Once I made that change, isn't everything the same as what we discussed yesterday? I'll wait till you're done writing and then ask the question again. Once you rewrite that first equation, isn't it exactly the same as what we were working on yesterday then?
Yeah.
Okay, good. All right. Am I way far ahead of anybody? Anybody need time to catch up? All right. Help me out here, guys. We've got some parentheses in this. So I've got 2x. Be careful on your distribution right here. What kind of 3 are you working with? All right, so help me. -3 times -7. Plus 21, right? -3 plus 3x. Negative how much x? There we go. All right, so distribution is complete. How about, what kind of 2 is that? 2 minus 9, right? -9, right? What's 2 minus 9, gang? -7x plus 21 is 7 still. Subtract 21. Putting it in my right pocket so I can write with my right hand.
Yeah.
Okay.
14.
What kind of 14? Yep. I've got -7x. All right, so talk to me about your x value, gang. X is +2. All right, now, if you can hear this note right here, or at least listen to this, I would make this suggestion here. Once you know that x is equal to the 2, we said we got to choose one of the equations to work with again, right? Now keep in mind, we had 2 original ones, but now we've got the third one that we changed, right? If you ever have to change an equation, go into the equation that you rewrote to solve for that variable. So right here, I'm going to say, well, you know what? Isn't this the equation you rewrote right there? Would you guys agree with that? Okay, so I'm going to rewrite that equation. So from the x equal 2, we know that y is going to equal negative 7. It says plus 3x, right? Right?
Yeah.
What are you throwing for x though now?
2.
So this is really plus 3 times 2, isn't it? And the reason I'm choosing that again, y is alone. That's the one we rewrote. So help me out. What's the product of 3 and 2? So this is really negative 7 plus 6 right here, which moves you to negative 1, right? So what's your y value here? Y equals negative 1. Okay. So let's see if we can't talk our way through that last one. By the way, I forgot to circle. X is 2, y is negative 1. Perfect. Guys, look at the problem number 2 in your notes that you have in front of you. Which variable do you think you're going to try to get all alone? Y. In the first equation or second equation?
Second.
So you are rewriting the second equation. So I want this y right here to be alone. So I got to get rid of a positive 2x. So if I get rid of a positive 2x right here, how did you do that?
Subtract it.
So if I subtract the 2x on the left, subtract it on the right. Okay, so we changed which equation again? Okay, so I'm going to rewrite my system. Do I have to change the first one at all? Do I have to change the first one at all? No. And then the second one's rewritten as y equals what?
1 minus 2x.
Okay, so this is the y that's alone. We're going to replace any y in the other equation with that I've underlined right here. All right, so somebody tell me how to rewrite that top equation. How am I going to rewrite the top equation? By substitution.
God x minus 2 parentheses 1 minus 2x.
And that equals what, Lauren?
Negative 11.
Good. Okay, you guys finish this up. Take a minute and finish this up. Once you've got a solution, I should say, once you have the solutions, check with someone. Okay? Check with someone. So take a minute and write that down. Again, don't forget, what kind of 2 are you distributing there to begin with? I felt kind of nice, I guess. I had some kids grade that, so they must have made a mistake. 1 point is not going to make a huge difference. It's like 0.00. I'm sorry. That's all right. I got coffee. Stunts my grill. What's my excuse? Started too late. Started too late. I like coffee, especially Starbucks. I could. You know that I've driven through Starbucks and drank cups of coffee, ran into Hy-Vee, and then went right through the drive-through again. And like, weren't you just here? I was like, yeah, it's so good. You know what? I'm not jingling change. All right, minions, do you need any more time? Okay, who's got answers? Yeah.
No, you said I got
Sure, tell me what you got.
I got x equals 1.
X is 1.
Yeah.
Alright, let's check it out. Did you get a y value, Lauren?
I couldn't figure that part out.
You guys agree with what I've got written down here by distribution? Again, negative 2 and 1, that'd be the negative 2. Negative 2 times negative 2x would be a positive 4x, wouldn't it? How about your positive 5x and positive 4x? Where's that putting you at? 9x. 9x minus 2 then is negative 11. I'm going to add 2 to both sides, where I would have 9x equal to negative 9. So Lauren, what kind of a 1 did you want here? You should have a negative 1 here, right guys? Right? So when I divide by 9, x is negative 1. Alright, your x value is negative 1. Now help me guys, I'm going to come right back up into here, because this is the one I rewrote, right? That's the one I rewrote. What are you going to throw in for this x value right here? Negative 1. So this is like negative 2 times negative 1, which is really positive 2. So this would be like a 1 plus a 2 when I throw out negative 1 in, wouldn't it? So y is equal to 1 plus 2. What's that make your y value? 3. That makes your y value a 3. So let me just explain that again one more time. If I throw a negative 1 in right here, that's like negative 2 times negative 1, isn't it, right? Which is really positive 2. Or now 1 plus 2 to make your y value of what again? 3. Okay. I think that's the end of the notes, isn't it?
Yeah.
Okay. That's the end there. And double check, make sure you got everything written down here that you need. Everybody on board with me? Okay. I'll go back to the book page. Make sure you guys have that. Everybody have this down right here. 292, 2 through 10, 13, 16, 18. Make note of the change of date. When's it due now? Tuesday. All right.